you can't interact with the ground without knowing how it works.
Ever wonder what it's like to work as a geotechnical engineer? What even is that, and why is it important? Well, today I had the absolute pleasure of speaking with Saskia Elliott, who you might know on social media as Sassie. But aside from her geoscience communication work online, she also works as a geotechnical engineer. So I asked her all of your geotech questions in this interview. So get ready to know a lot more about this career. Let's get into it.
Hiya, yes, so my name is Saskia. I am a geotechnical engineer, and also I'm online as Sassie, and I do educational videos as well.
Yeah, I do want to highlight your incredible geocommunication work. You've been a huge inspiration for what I do, so thank you for that. And now you're more on YouTube, which is kind of where I am. So I love seeing your videos pop up and sharing them with my audience. I think there's a lot of overlap, and hopefully one day I can go there and we can do a collab where I get to find some of those amazing fossils. I get so jealous when I see that.
Literally, I've got like the ultimate playground here. So like my stuff that I do online is quite different to my day job, which is because I very rarely actually talk about my day job. But it's just because I've got like a playground of an entire coastline of World Heritage Site geology. So I talk about that in my videos and then sort of miss out my job.
Yeah, no, I mean, you do have a playground. I'm very jealous. But for this video, let's talk about the thing you don't get to talk about very often, that day job, which is still super cool. And I know very little about it, and it's in geotechnical engineering. And
Yes.
that I also got a viewer question that essentially put it, describe geotechnical engineering as though you were explaining it to a child. And this is definitely going to be helpful for me because I don't know anything. So let's hear what you can how you can explain it.
So it's basically like the soil movement, shall we say. So I particularly focus on coastal areas. So for me, that might be landslides, so how that sort of weathered stuff is moving around. But previous jobs, I've also worked in it for construction. So, if you're going to put some sort of building foundations in, you need to know how the soil is going to move around it. There's quite a lot of complexities beyond that, but really you're looking at the weathered soily stuff and how it moves. It's like a physics problem.
That is so cool. I've always leaned away from physics. I literally did biogeochemistry for my grad work. So I did everything but the physics because that is too much for me. So that is super cool for me to hear. It also sounds incredibly important, which we'll get into. But first, can you describe like a typical day or week on the job for you and how often or like what's the ratio of field to office work?
It can be quite varied. So, for example, this morning, I haven't actually brushed my hair since I was out on the coast being wind blasted. So sometimes I'm out looking at things, but then normally I'm back in the office writing reports, analysing up what I've seen. So it can be either an entire day out observing, taking measurements, recording, but equally then you can have a whole week just solid reading reports, trying to work out sort of like the answers to the problems that you're maybe asking. I would say that it depends on what sort of part of it you're in. So this one that I'm in now, it's more office-based, whereas the role that I used to do, I would sometimes be on site for like 2 weeks and then back in the office for 2 weeks. And the nature of what I do now is a bit more local, so I can afford to go out for a morning and come back. But yeah, previously, sometimes you'd be off in an Airbnb for quite a while.
Okay, and I had this question table for later, but we'll do it now since you mentioned it. But what did you used to do? What was your previous role, and how does that compare to what you do now?
So fresh out of university, I went to go and be a geo-environmental consultant. But because my background in my sort of uni stage had a bit of engineering in it, I kind of did a bit of contaminated land and a bit of geotech. So a lot of construction projects that we ended up working on, you kind of needed a little bit of both anyway. So I'm not entirely sure how it works in the US, but for us, if you've got a big commercial development about to happen, they need to know, obviously, what's under the ground before you start doing anything. So that will normally involve sending a little site monkey out to go and investigate the ground, find out what you're dealing with. And that's done via like We used to do big trial pits with big JCBs, which was great fun. Boreholes, sort of water sampling, soil sampling, all these different like mesh of ways of investigating the ground to get sort of the chemical properties or the physical properties so that you can then build an idea of how you might be able to develop this site, which was quite fun, actually. I really quite enjoyed it.
That does sound really fun and just really incredibly important to, how we build things, how we, live on our planet, which is this big geological hunk of rock that has processes we have to understand and materials we have to understand to live on it.
Yeah, I mean, so you can't interact with the ground without knowing how it works. Therefore, you need a geologist. Whether that is you want water supply, you need to understand, has any of the contamination from my landfill over here managed to infiltrate that water supply? That was something you would have to look at in my role. Equally, it could be, so in the UK particularly, we have a lot of building over a lot of time. So like in central London, sometimes you can have 10 meters of man-made material before you even hit natural soil. So we kind of got to deal with the legacy of what humans have already left behind. And that's an engineering problem in itself. We used to do quite a lot in London, and it would be sort of, you would drill down, have to treat the made ground, which is what we would call it, like the human stuff, as one thing, before we then started actually working out what we could do with the stuff underneath. So a lot of London's built on massive like pile-driven structures because you've got to get past the human bit and interact with the natural soil, because the human bit's really like, here's a brick, here's a bit of an ash. Like, you can't put weight on those things. You don't know how it's going to react. So particularly as humans continue to build on top of themselves, which would be nice rather than going out into green areas, we really need to understand how you engineer on top of what we've already got, which can be quite a fascinating thing to dig through, if I'm honest.
That is really incredible. I never knew so much of land was already what we've put there. That is really crazy and something that you'd have to, really understand.
Yeah, and really important to, like, I mean, there's obviously all the other aspect of you need to understand how to drill utility lines. So if you want, particularly in the UK, obviously we're an island. So if we want to put offshore wind, you have to understand how to lay the cables in a way that's not going to impact. Again, that ends up becoming a geotechnical problem. So you suddenly sort of start realizing that how we interact with the planet, you need to understand how to interact with the soil. And it's so far reaching, it kind of breaks your brain a little bit. Like there's so many niches within it. It's such an in-demand field because my bit's coastal. Equally, I've done a bit of contamination and sort of city engineering. But I've got other entire friends who do other complete sections that I have not a lot of idea about.
Oh my gosh, that is so interesting. And what would you say is kind of the breakdown of geology versus engineering versus kind of a combination of the two in your current job?
So I would say I am a geologist. I've technically got an engineering-based degree, but I'm a geologist. Mainly because I wouldn't trust me to engineer a massive building, for example. That's not my bag. I do rocks. So ask me about how the rocks are looking, how the rocks might move, how the human bit of engineering against the rock is looking. I can get to that bit. But, I am a geologist. I'm fundamentally looking at the structure of the rock. So I'm geotechnical soil engineer. And you've got to really have an understanding of how the rocks go down. So a lot of my area is all sedimentary, and I need to understand how the rocks were deposited to help me engineer it. So, for example, if you've got an old little river channel going through, that's going to act as an area for water drainage that could then impact my cliff. So if, say this is like a bird's eye view, and I've got a river that's going out here and out to sea, I need to make sure that my engineering solution adapts for the fact that water comes through here. I don't need to worry about it here. So you have to use your geological brain to help the engineering side of it, which is, it's every single little package of land that you face is like a separate little puzzle, which is why I love it.
I love how you just put that because I feel like there's so many geology students that are currently in said strat, like sedimentology and stratigraphy class, and they're like, why are we learning this? Why do we need to know how the rocks layers were deposited and what depositional environment this is and where the river is going and how it's moving through the landscape and altering the landscape. And engineering students have to sometimes take geology classes depending on what kind of engineering they want to do, and they're probably wondering why is this relevant, and exactly what you just said is why.
I always had a weak spot for sedimentology. That was always the bit that I liked. So I found a way to kind of, I was also always a physics geek, so I kind of found a way to knit the two together. It was
The
quite
perfect,
handy, actually.
yeah, the perfect combination. That's amazing. And going back to that, what initially inspired you to pursue this line of work, whether it be just what initially got you interested in geology or engineering, or what came first for you?
It's it's been a road, a winding one.
Isn't it
So
always?
literally, so my initial like for geology came really from college age, which for us is like 16, 17, 18 age. I didn't know, like, I'd grown up on the Jurassic Coast, loved it, loved fossil hunting, but didn't consider that that was a career. Like, that was just the fun weekend stuff. And this, I wish I could remember his name to give him a shout out, but there was this little guy at an open evening, and he was like, "Have you heard of geology?" And I was like, "Okay, this guy's very enthusiastic, whatever." Like, and then he kept talking, and I was like, "Actually, this sounds really interesting." Um, and I took it as my relaxation subject because we were allowed to take three options, and I didn't intend to carry it on, and I loved it. And I was just like, this is like an outdoor science. Amazing. But that obviously was just the geology side. The engineering side actually didn't come until I pretty much finished my bachelor's. So I had no idea where I was going. I just knew I liked rocks. Um, I was graduating in 2020. You might remember there was quite a big world event in 2020. So I suddenly realised that in that summer, there were no jobs anywhere. So I had to do something. So I was like, now looks like a good time to do a master's degree. And I was looking at, I had like an alumni discount to stay on at my current university. So I was like, guess I'll pick from this list then. Wasn't really driven by anything until my parents' house that I was living in, suddenly they realized that there was a crack in their floor. And I was like, whatever, it's a them problem. And we ended up having to have a borehole drilled in my bedroom at the time, and then another one in the lounge.
Oh
And
my
I
gosh.
suddenly, like, it all came in at the perfect time for me to go, oh my God, there's like rocks under the house, and like there's an engineering thing here. And it turned out basically that the packing that was under our foundations, all the fine stuff had been washed away by water, and our foundations were just floating. And it was very expensive for them to fix, but they fixed it, and that's fine. But for me, I was like, there is an engineering aspect here that I'd never thought of. And I looked down my list, saw engineering geology was an option, and went,
There
sounds
you
like a good
go.
choice. So
Wow.
it was very coincidental, and mainly driven by the fact that I had a borehole in my wardrobe for a while. Like,
Oh my gosh, I love that. I love that it was like a personal experience that was like your moment of realization. That is so cool.
I
Wow.
was so gutted when they took away the concrete core. Like, I was like, no, that was my precious. Like, and they took it
Oh,
away and
that's
disposed of it. I was like, no, you could have left that here. But I've still got photos to this day that I'd like shoved my hand under the concrete to try and take photos. It wasn't very exciting, but it does say the level of inspired I was.
Oh, that's such a geology thing to do. That's amazing. Speaking of personal experiences or job experiences, what is the coolest or craziest experience you've had in your either your previous role or your current role?
The coolest experience I had was actually in a little job that I did for an interim between the careery geotechnical stuff. I worked for the Jurassic Coast Trust, and I had this amazing day that I got to go kayaking out round. We've got this rock feature called Old Harry Rocks, which that'd be a good point to have a picture. Um, but I got to go kayaking around this to explain and talk to some of the locals about geology so that they could then teach schools when they came on trips. So the theory being it was like dispersing information and geology education out there so that it could be passed on. And I was like kayaking going like, this is probably the coolest day of work I'm ever gonna have. Like,
Seriously. Oh my
yeah,
God. That's incredible. What an experience. Yeah, I
it's
remember
just,
my first field experience was rafting in Glacier National Park, and I know. I was like, we went even up into Canada. Oh my God, it was so beautiful. I was like, well, okay, geology it is.
I think
It's
field work
decided.
sells it for lots of people.
Yeah, and then I ended up going and doing a PhD that was never once in the field. It was fully inside in a lab. But you know what? I loved it all.
You were already hooked by that point. They had
I
you.
was. They had me. It was
Yeah.
over.
I did
10.
have a particularly, should we say, amusing one as well, that was the opposite end of the spectrum, which was like, and I'm doing this for a job, which was hilarious in the contaminated land side of things. It was pretty crazy because we were digging through this site that we thought was just a car park, and we were like, it's fine. I will leave the location undisclosed. But we started digging up this like plasticky stuff, and we were like, this is really weird. What is it? And someone went up with a pencil to like pick up some of like the spoil that was coming out. And it turns out what we had been digging through was all of the sort of leftover stuff from a sewage plant net. And what we were picking up was just piles of condoms, and like they even had knots in the end, like bits of glove, bits of earbud. I did not
No.
sample that material. I took one look at it, and I had to write on my like log, which went off to the client and all got official. And from this step to this step was condoms. It was like,
No. Oh my gosh. That is
yeah,
a story.
yeah, it was one of those that you sort of got to the end of the day, phoned your line manager, was like, you'll never guess what we've seen today. Yeah,
What,
so
that is like, oh my gosh, the experiences of a field geologist.
yeah, and like anyone who's worked in that sort of site investigation side of it, like everyone has their war story, and that was definitely my one that I like and that was within the first 6 months of being a graduate, and I was like, what have I gotten into? But it never was that bad again. Like all the other sites were lovely, like that was just, but it got me such good street cred straight away to be like, yeah, you say you've had weird one, I've had the grossest one.
You stuck with it though. That really shows the testament to your motivation and your commitment to the field. Amazing.
It was only 2 days, the rest of the site was fine. It's just one little area, the rest was fine.
Oh, that is so funny. Oh my gosh.
It's
Okay,
grim.
on a different, more kind of inspiring note, have you had an experience that made you feel you were really making a difference, whether it be like environmentally or in society?
I'm really happy to say there's been multiple. Like,
Aw.
so in the initial contaminated land side of things, there was a particular project that I worked on that it was quite amazing because we had this like natural chalk stream going through it, which for anyone who isn't aware, chalk streams are, I think we've got like 80% of them in the UK. Fact check that figure, but like it's one of the rarest types of river outlet. And I happened to have one going through my site, and I was like, okie doke, this could be worrying. And over the course of how long I was on this site, I slowly saw some of the wildlife like creeping back into it because they were like decommissioning a sort of fairly industrial site.
Yeah.
They were going to build something else on it afterwards, but in a way that was more sympathetic to the industrial site that had been there. And that was one of those I was like, wow, I'm literally over the course of one project watching an area be like renaturized. So that one was pretty awesome. Quite loved that one. And then my sort of like interim job, I also did some awesome stuff for the World Heritage Site that I just little legacy things that I could leave behind, asked questions in some rooms that people hadn't necessarily thought of. That I know I've left a little impact that will keep people thinking about geological heritage, which that was my little stamp of like, I did something that I can see worked here. Like,
Wow.
who knows? Hopefully I'll get one in this job as well. I've just not been in it very long yet.
Oh yeah, yeah. You just started, didn't, was it a month?
Yeah, so
Wow.
I'm only a month into the new role. Like it's still very reminiscent of stuff that I've done previously.
Right.
So I'd done the geotech side of things, and I'd done coastal, and now I'm doing coastal geotech. So it's sort of like
Perfect.
I kind of walked in knowing some of it, but there's also a hell of a lot to learn, and
Oh yeah.
I was spotting up only a couple of hours ago still. So.
Wow, that's awesome. You just mentioned kind of some of your experiences with, environmental impacts that your workers had. I'm curious, what are some of the environmental considerations that you have to take into account on the engineering projects you do and kind of how that works?
So quite a lot is the answer. In the UK, we have this thing called biodiversity net gain. That was something that we often had to remind clients, which is that anytime they redeveloped a site, you have to put 10% more biodiversity on the site than you started.
Wow.
So, which is a really nice thing. I mean, there's some quirks with it that I think people will try and get around by just sort of buying green credits and that classic old thing. But at least the initial motive of it is nice. It's just so long as people action it as it was originally intended. But you've got things like that. And then if it was an area that obviously was super ecologically sensitive, we had to be super careful in our drilling activities and things. So I often worked with, like, I'd have an ecologist on site making sure that if I needed to get into that bush, they would have to come and clear the bush, make sure there was nothing delicate in there, or there was one that I remember going, oh my God, because I brought my JCB in and we were like, okay, right, we're ready to dig this hole. And she went, yes, turn around, went, stop. And we were like, oh my gosh, what? And there was a rare orchid about this far from the track of our JCB, which she openly, she said, I hadn't spotted it either. Don't worry, she said, but I am just going to go and replant it really quickly. It's this super rare orchid. And I was like, oh my God.
Oh my gosh. No, that's crazy. Speaking of people that you have come on site and that you work with often, who are the people you work with most often? Like civil engineers, architects, environmental scientists, regulators?
All sorts. So my first role, I was very much the contractor who went out and did things. So I would be working with like local governments, I'd be working with developers, but equally then on the ground, I'd be dealing with sort of like the just day-to-day people who were using the sites. So it was a lot of interacting with the public, which leads to all kinds of fun. Then in my next role, I ended up working a lot with sort of Natural England, which is a sort of government body for all things nature in the UK. And with that one, I ended up, interacting with so many people I never thought I would, like sort of heritage-related organisations or governmenty type things, but also like local businesses and different sort of local museums and things. So that was a whole little package. And then the one that I'm currently in, again, I'm working with the public because I'm sort of governmental based, but equally I'm now going back to consultants and asking questions of them and becoming the middleman, but on the other side of the fence. There's sort of like a natural way that all construction projects work. And I've so far managed to just sort of dot around all the different parts of, but there's always going to be natural interactions with like civil engineers or structural engineers, and again, even archaeologists. So again, back in previous role, we have a lot of archaeology in the UK. So I would have to sometimes check that my JCB wasn't going to go and rip up anything of value. So I'd have to bring an archaeologist out and we'd both be watching the shower pit as it happened. So there's so many different segments of careers and people that you don't even think you're going to interact with until suddenly you've got a job that you have to, which I enjoy that. Keeps it interesting. In fact, even unexploded bomb ordnance guys, because World War II happened and we got bombed quite a lot in World War II. So if you're drilling boreholes, you have to make sure that, and sometimes we can be talking 10, 15 meters below ground level, have to make sure I'm not going to hit a bomb. So I would have,
that's kind of terrifying.
Yeah, and we had a couple of scares that the bomb detecting chap would put his device down and he'd go, no, you can't keep drilling that. And we're like, can you tell us what it is? And he's like, I can't tell you because I can't see it. But he said it's about this big and it's metal and it's oblong. I was like, yeah, we won't touch that. We'll go over here now. So,
oh my God.
All the considerations that you don't necessarily think of that add to some fun of site work.
Wow. Oh my gosh. That never would have guessed. Wow.
Keeps you quiet when you're trying to work out how to, so you've got all the geology on the back of your mind, but sorry if you can hear a dog barking. So you've got all the like geological considerations of a site in the back of your mind, but also all the modern things on top of it and the logistics of what you're doing, which is, it can be a nightmare, but It's quite buzzy. It's quite exciting when you're part of it. I
Oh
enjoy it.
yeah. Yeah, I bet. I bet that's exciting. I wonder if we'll find a bomb today.
Yeah, who knows? Maybe a rare orchid, maybe a bomb. Who knows?
Oh my God. Okay, last question before we get to viewer questions, which are always so fun. What's something you wish more people understood about the role of geology in construction and other aspects of engineering?
Is that it's very important. If geology is ignored, especially in large projects, it can lead to problems. And I have frequently seen cases where maybe a geological recommendation was put across, as in, maybe you should use this sort of foundation, but it might have been more expensive. But then 20 years later, the building's cracking, and that was probably why the recommendation was put in. So we're not just geeks saying it for fun. Normally, there's a reason as to what we're saying. And it can be sounding like we're quite risk averse, but it's normally because there is a risk, especially, I mean, with like subsidence and landslides and building settlement, you can't afford to get that wrong. So it's quite important to have someone assessing the ground before you build on it.
So well said. And yes, so important. Okay, to fun viewer questions. And some of these are, might be out of your expertise or experience, and that's fine. So just answer whatever you know or have experience in. But the first one is, are there any emergency services your field provides for communities recently affected by earthquakes or other land altering disasters?
So not one that I directly work in, but actually one of my old lecturers, he used to work in sort of like forensic landslide investigation. So
Oh,
he used to, when there'd been a big landslide, go back and sort of work out where it come from and try and sort of plan some of the disaster response based on what they'd investigated, which it looked fascinating. That's especially, I know, quite a thing in like China where they've got a lot of landslides that happen over there. We don't need to worry about that on the coast quite so much, thankfully. But it's more sort of where there's highways involved or some like a train line and that sort of thing. So it can be quite important to sort of like forensically pack it apart to plan a disaster response, which is quite interesting.
that is so cool. Never heard that, like those words used together. That
I mean,
forensic landslide analysis. What? That's so cool.
I've actually got a whole book that I have embarrassingly only read like the first 10 pages of, but it's all on like forensic landslide analysis, like trying to reconstruct how it, so you come to it and it's fallen down, and how do you reconstruct to
Yeah.
see how it fell down, which I
Wow.
haven't got to the end, but I'll tell you if it was interesting when I eventually do.
That's so cool. And that's so much of what like geologists do. I mean, landslides are relatively like new, recent events, but like, I mean, even what I studied for billions of years ago, that was reconstructing, somewhat forensically, more geochemically, but forensically reconstructing what happened, so many years ago, which is a lot of geology and is so important for our understanding of not just hazards, but like what is going on today globally in terms of global geologic, global climate processes, environmental processes, life, and how, it's all working together to bring us into a future that's hopefully there. But
Like,
it's so cool.
problem really is like, it's like you've got to be Sherlock Holmes and like piece together as much as you can to solve and like deduce what the issue was. And I think that's what's fun about geology. The rocks can't talk to you, so you've got to puzzle it out. And
Yeah.
I like the puzzles.
I know. I feel like all geologists just love like puzzle solving. It's so cool. It's so fun. And speaking of puzzle solving and how we do it, are there any new or emerging technologies that you're excited about?
So many. The one that I'm particularly excited about at the moment is all to do with like drones, lidar, and like remote sensing. So obviously, if you can prevent yourself going into a dangerous area, that is ideal. And I've been lucky enough to work on some projects fairly recently that I've been able to go along and go, we think there's been some movement. Let's send in a drone and double check. And sometimes you could be pleasantly surprised and go, oh, no, that was just a shadow. Turns out it was fine. The drones managed to solve it, so we didn't have to put anyone in harm's way. Great. But equally, like LiDAR can detect any sort of vertical movement. So if you want to get a good assessment of a wide area that you think might be in problems, send the LiDAR drone over for frequent surveys every, I don't know, few months or whatever, and you can see if the ground is slowly moving. And that's a really interesting way of identifying how things might move over time. And there's some that are like satellite based as well, like I think it's called INSAR. And again, that monitors the tiniest millimeter movements, so you can get an early warning system of the ground is about to start moving before you've even seen the big cracks starting to form. So stuff like that is phenomenally exciting for ground movement, which that's the bit that gets me geeky and excited.
And it's like so amazing how precise we can get now with these technologies. And, remote sensing and, drones and LiDAR drones and all these things that we can use to go do the things that we don't want to do in person isn't just helpful to have, take less time, takes less person power to go do that. But also, like you said, these places can be dangerous. So having that be remotely done is not only, helpful for decreasing danger, but also can, and Jess and I just talked about this in mining geology too. There's a lot more remote sensing, remote, technology being employed to study mines and work in mining geology, which leads to also more accessible jobs and positions where people that maybe have, physical disabilities can go into geology when in the past, when everything was done in person or in the field, they couldn't, and now they can. So it's just opening up a lot of possibilities too, which is just so cool.
Yeah, I mean, like most of my day job tends to be sat at a desk. Like I get the fun beach trips, but that's more to truth check. And realistically, someone else can do that as well. So yeah, most of it can be monitored from a laptop. And by the time you've got there's so many, I can't go through them all, but there's so many cool types of sensors out there that even so they're not always just vertical. Sometimes they'll even measure like the angle. So you can put a sort of like tilt meter or an inclinometer in, and it will measure. And I think the one that I saw the other day went down to 0.002 of a degree of accuracy. So the slightest change in that slope, because a lot of landslides sort of rotate as they slide. So you can get like an early warning thing emailed straight to your account that says, by the way, sensor 157 has just tilted by like 0.5 of a degree. You might want to go and check that out. Like that sort of technology is phenomenal.
I didn't know that. That's really cool. Oh my gosh, things are just so advanced these days. I'm curious. So I guess those are things making the field less challenging. But are there any challenges in your field? And again, I'm curious, but this was also a viewer question. Are there any challenges in your field that most people wouldn't think of?
Generally, the logistics, actually, like the geology bit is pretty self-explanatory. It's the logistics of getting things mobilized and getting people to a site. So if, for example, I've got a coastal cliff and I want to monitor the cliff, I've got to get a rope access team. I can't just send someone for a little walk. It's the logistics of then, okay, so in order to put the rope access team on, I've got to have a safe zone at the top. Okay, so who do I contact about that? Like every single little tiny thing has logistics issues that you don't even think of. But I mean, I'm hoping, 10 years time, I'll be trotting along and I'll foresee all the issues before they ever happen. But I am under 5 years into my career, so sometimes I do come across things and take it to a manager and they'll go, oh, before you go down that line, there's a like rare lizard you need to think about on that area. And I'm like, okay, sure, of course there is. Who do I talk to about that?
Wow. Considerations I never would have guessed. That's so funny. Yeah. Oh my gosh. Rare lizards. Never would have thought it.
Oh, I definitely had rare lizards grind an entire site to a halt and like by the time I left the company, the site still hadn't gone ahead. Like the lizards come first.
That's like encouraging. I love that. Yeah. That's really good. I mean, it's hard, but like makes me feel good about the ecology of it all.
Yeah, we have we have lots of protected species over here and lots of these things called triple SIs, which are sites of special scientific interest. And they protect everything from like a particular grassland to a plant to even sometimes the rocks, which is quite nice. We actually have designations to protect rocks. But yeah, equally, if you're trying to work within these triple SI areas, you have to be really mindful of what makes it special. And there's a lot in place to stop you from doing anything you shouldn't.
That's great. That's really good to know. And speaking of environmental considerations, and I know you might not be directly involved in working on building these things, but do you see or do you foresee any serious issues when it comes to building renewable energy technology like wind turbines, hydroelectric dams, or geothermal stations?
So, I mean, I must admit, dams, I don't know a lot about, but I have a couple of friends who've sort of worked in and around the wind turbine type of things because we've got a lot of water around the UK and they look at doing a lot of offshore. And there's so many environmental considerations that you have to, again, logistics that you have to think about whilst also doing the geotech side. So if you need to get the electrics back to land, you have to dig a trench, or the chances are it's gone through a fish breeding ground or something similar. And you have to be mindful that when you put in the foundations of said wind turbine, you've completely destroyed a little patch. And now you've got a network of these big foundations. And what does that do? Because that can even then affect like the waves as they come into shore, which then can affect, like, it's the more you think about the earth, it's this massive network that everything affects everything.
Yes, interconnected. Everything is. Wow.
Yeah. And I know there's been sort of wind turbine farms that have been rejected on the basis that they'll affect the wave climate on land too much, which is nuts. Like, but these things exist and they are things we have to consider. So yeah, that's quite a fun one. And geothermal wise, like, I love the idea of geothermal. I got very geeky at a conference not too long ago talking to someone, but might surprise you to hear. I think geothermal is an absolutely brilliant one because I would like to see more of, like, when we drill a hole, can we like convert that into being something for geothermal? I know there was a site that I worked on at one point that I was drilling a hole to about 30 meters or so. And a random passerby member of the public came up and said, "Oh yeah, did you know there's like a geothermal well just sort of under that building over there?" And he sort of gestured. I was like, "Oh no," and I said, "Oh," he said, "I thought you were doing one here." I was like, "No, this is just for sort of soil properties." And he went, "Oh," he said, "Well, we only went to like sort of 50, 100 meters. Like, you could just put one in there." And I mean, I don't know what his qualifications were, but it did sort of get me thinking, like, if we're drilling lots of holes, why can't we do a bit more geothermal?
Yeah.
Someone might have a good answer for that, but that's my take.
Not right up your alley, but very interesting. Oh my gosh, that is so funny. I love that it was just a random passerby.
Yeah, I mean, generally, when you're doing any sort of like site work with drilling, you are very obvious. And you've got a lot of curious members of the public coming up to your fencing going, "So what are you doing here then?" And it's either, "You're drilling for oil? You found any gold yet?" Like, you hear the same things every single time. No.
Found any gold yet? Yep, that's a very common one. Okay, so another viewer question is, how do you test materials to determine if they're suitable for different geotechnical uses? For example, how would a slope be tested for stability in a building project?
There's sort of two sides to this one. So if you're using materials for building, like an aggregate or something like that, the general stuff will undergo lab testing generally, and there is so many soil lab tests that there's books written on it. Like, it can be everything from like, what's the percentage of like gravelly bits to silt to clay, and yes, there's like entire descriptions on like, this is a slightly sandy, gravelly, silty clay, and it's nuts. But they
Oh yeah, and the difference between things like silty sand and sandy silt. Oh yeah.
oh yeah. But we have that sort of lab test, but loads obviously on sort of strength and bearing capacity type things. So they'll do different compression tests, different shearing tests, just to sort of understand how the material might react, or even, especially for things like a silt, what's the water content, and if we add a certain amount of moisture, will it bend, will it just crack, what happens to it? So there's entire labs set up just to test soil and its properties, which is mental. So once you've got that, obviously you can then take it to your site and know how to engineer with it, which is really cool. And there's a lot of schemes where they try and, like, if you're cutting a whole bunch of material out of one area, sending some of it off for testing so that you can then use that and recycle it somewhere else within the project. So you don't have to generate extra waste or anything, which that's quite clever. But on the other side, for like materials testing on slopes, there is some insane engineering that they do with different sort of tracked vehicles that can like counterlever at different angles, or they even have like sort of rigs that will sort of sit on the flat bit at the base and then just drill into the cliff that way. Like there's so many different engineering solutions for how to drill on a cliff without actually getting in like onto the cliff edge. It's if you can think of it, someone's probably had to solve this problem at some point. So it can be really fascinating to see how they get that into a building project.
Oh my gosh, that's wild. Okay, and finally getting to the viewer questions that are more on the side of future student related things. The first one is, what kind of education and training did you get to help you pursue this career? And what advice do you have for students that want to go into this?
So I did bachelor's in pure geology, and then I did a master's in engineering geology. In the UK, I would say seems to be about 50-50 as to whether people have the masters or not. I'm personally really glad I did it. I think it gave me a lot of confidence for when I first started, because when they were then talking about things, I already had like a frame of reference. But equally, I know people who've gone into like the environmental side of things and they've only sort of had just the base level degree, and it might have been in like environmental geology or something. So there's lots of different routes, and I think because it's a topic that is so needed for construction, companies are often quite open to how you get into it. Like, so long as you are enthusiastic, you can, driving license is an almost essential qualification because you need to be able to get around. But so long as you're like enthusiastic, you're happy to learn quickly, and you've got the base level of information, they tend to be quite adaptable as to who comes in. And I know, particularly in the company that I used to work in, graduates who came in, often you get lots of the same qualifications, but it's sometimes actually personality that sort of dictates whether you succeed or not. Because if you're going to be on site and you can't talk to the drillers because you're really, really quiet, you might not be good on the site work. You might be better in the office side. There's still a place for everyone, but I would say actually social skills are quite an important one for site work. It's probably why I stopped, but
Okay, I'm surprised at that. I was going into this assuming like master's degree would be like needed or preferred, but that's good to know, especially for students that maybe aren't planning on going for that master's or don't know whether they should. That's really good to know. And I know with Jess, when we talked about mining geology, there was the possibility that you could just graduate with your bachelor's, then go into it, have a company actually fund you to get your master's. So is that a thing also in this field?
Yeah, absolutely. So I know a couple of people who've done that, or they have done like master's level top-up courses that just do like a couple of modules rather than the whole thing. I would say personally I enjoyed doing the master's first, but yeah, I definitely know in the little group of graduates that I sort of started my career with, I think out of like 5 or 6 of us, I was the only one who had a master's at that point. So,
Wow.
and I think it also
Yeah.
depends on whether you're going to go into like the big international consultancy, or whether you're going to go to like the small contractor who just does Devon and Cornwall or something like that.
Yeah. Yeah.
It
Absolutely.
depends on what level of career you want to go for.
Another question that a viewer asked is, geotechnical and engineering go hand in hand. So are you a PG, professional geologist, or a PE, professional engineer, or neither? And can you give us any insight as to which path might be better for somebody who might want to pursue this career?
So I am neither, because we don't have that in the UK.
Oh,
So
okay.
yeah, no, so we tend to have chartership in the UK, which I guess is our equivalent. And sort of like me, I am not chartered yet. They tend to assume that you need 5+ years in sort of employment before you can even go for chartership. So it's not a requirement of getting a job. It's something you get after a certain amount of time in one.
Oh.
And so like my chosen, like, because I'm trying to track all my CPD, my continued development, and I'm looking at doing it for the Geological Society of London, which would be a chartered geologist. Equally, you can go down the engineering side and get chartered with the Institute of Civil Engineers, I feel comfortable in geology, so I'm going for geology. But a lot of the sort of higher ups that I know are split between the two. Particularly in geotech, they tend to lean towards the geology ones, but there is a bit of both out there. So I don't actually know how the professional geologist or professional engineer works over there, but we have to go through like putting together some documentation and then going for like interviews, and you get like an oral exam that you have to sort of prove you've done the job and you know what you're talking about. So it's quite epic to prepare for, and you have to have like a certain amount of people who can say they've worked with you and all that sort of thing. So I will be getting there at some point, but I'm not quite there yet.
Wow, that's so interesting. Yeah, over here, I'm not entirely sure either because I am in academia and I don't need any of that. But to my understanding, it's just like a test you go take. And I don't think it's oral. I think it's written. And some states require it to work as a state geologist or, something like that. But I will probably have another person on from the actual US that can give more information on that. But that's really interesting. And kind of related to that, and this wasn't a viewer question, but now I'm thinking about it and people probably are wondering it. But would you say that, if there's a student out there that's wondering what they should focus on if they want to do this career, should they focus more on the geology, more on the engineering, or I know with Jess similarly too, I'm sure this career, she mentioned that it kind of didn't matter so much. It just depended on what interests you. And then later, once you get into the job, they kind of, wipe you clean and teach you everything you need to know. Is it the same?
I would say it's a lot of that. So I think you could kind of have, it's particularly the graduate stuff I've been into, you could have any role and they would mold you into what they needed you to be. Obviously, then as you move on into your career a little bit, and again, I'm only 4 years into my career and I've had 3 jobs. So each one has been a little bit different. But by the time I'm in the one I'm in now, they're sort of like, okay, we expect you to have done X, Y, Z. But the first graduate role I went in, they were like, we expect you to be enthusiastic and have done a degree.
Right?
It was more about your quickness at learning rather than perfectly knowing everything from day one, which from what I've spoken to, a lot of graduate schemes are like that. Like you can't obviously go into geotechnical engineering with a degree in English. Like you've got to have some base knowledge, but so long as it's related, they're going to train you up from a graduate program.
Oh, yeah. Yeah, that's kind of a common theme I'm noticing the more I talk to people as well, is that school just teaches them how to learn effectively in that broad topic field. And then the job teaches them what they need to do, which, seems to be a common theme.
And I think it teaches you what niche you're going to, like, I think everyone gets so set on the first graduate job you have has got to be the perfect graduate job. But, if you really want a wild story, the first graduate job I ever did, I lasted 2 weeks and I walked out. That's how good that went. You can have it all planned out. You can pretty much be like, yes, this is what I'm going to do. But your career will take paths that you don't expect it to. And so long as you can find something you enjoy, it will come out all right in the end. You've just got to keep pulling the threads of what makes you curious.
Oh, yeah. Yeah, absolutely. Could not agree more. And with that, the last couple of questions I always like to ask, what is your least favorite part of the job? And what is your favorite part?
So my least favorite part is when I'm having to do a report and I'm looking out the window and it's really sunny and I know that I could be on the beach in that moment. Like I'm writing about the beach and I'm indoors and it's sunny. And we don't get a huge amount of sunny days in the UK. So when I'm trapped on my laptop looking at all the pictures of what I could be enjoying, that really sucks. Sort of on the flip side of that, the best days are the ones that I get to go out and put it in practice. And I get to go outside, have an ice cream, look at a landslide and go like, yeah, this is epic. This is nature. And now I'll go and write the report on it.
Absolutely. Except for the days where you find piles of condoms. But other than that, the field is amazing.
There was only like 2 days ever of my career.
But it makes a funny story. So it's still good.
Oh, yeah, absolutely.
Oh my gosh, that's amazing. It's been so great having you come on and share your story and your kind of varied but related background and all your roles. I think this is going to shed a lot of light on what graduates can do in geology and engineering and related fields. So thank you so much.
So